afternoon, guys. How are you today? So, our topic is energy and power. So, at the end of this lesson, the student should be able to define energy, state two sources of energy, state at least 5 forms of energy, carry out simple calculations involving electrical energy, should be able to define power, carry out some simple calculations involving mechanical power, and solve problems involving electrical power. So, we know already that energy is the ability to do work, and the energy unit is in joules. We know the two sources of energy. We have the renewable and the non-renewable sources of energy. And under the renewable source of energy, these are sources of energy that cannot be exhausted. Example, the solar energy, that is energy from the sun. You can't exhaust it actually. You cannot finish. The wind energy, no wind now. The wind energy too, it can't be exhausted. The hydro energy, that is water energy, it cannot also be exhausted. They exist naturally in nature actually, and are always available for man to explore. So they are called renewable source of energy. Do you get? So when you're talking about renewable source of energy, from the word renewable, they can be renewed actually, and they cannot be exhausted. But non-renewable source of energy, these ones can get exhausted with time. They are available in different forms. It includes energy like petroleum fuels now can be exhausted. Liquefied natural gas can be exhausted. Solid fuel like firewood, grass, paper, petrol, diesel, etc. can also be exhausted. So all these are under the category of the non-renewable source of energy. So now the types of energy are different from forms of energy. So now we'll be talking about forms of energy. Number one is the chemical energy. These are energy stored in food, petrol, natural gas, or diesel. Chemical, when we talk about chemical, we're talking about reactions now. Anytime you're talking about chemicals, you're talking about reaction. So when you eat, there's a way it reacts in your body. So there's an energy stored in food. Do you get? So they are all called chemical energy. These are energy stored in food, in petrol, in natural gas, in diesel, and etc. And they can be converted into one form to another for use. So they are called chemical energy. So electrical energy. These are energy used in powering our electrical appliances at home and offices. It is obtained from electric current flowing in a circuit. So that is electrical energy. For the mechanical energy now, this is the energy experienced by a body undergoing motion. So anything mechanical is undergoing motion. Anything electrical, it's involving powering, is involving electricity. So under this mechanical now is talking about a body undergoing motion, and we have two forms of mechanical energy. We have what? Two forms of mechanical energy. The first one is called the potential energy, and the second one is called the kinetic energy. The potential energy is the energy of a body at rest. So when the body is at rest, the energy is called potential energy. That is when the body is not moving. It's called potential energy. That is, it has the potential. Okay? It has the potential, but it is at rest. Kinetic energy, this is the energy of a body in motion. Anything kinetic means it's already in motion. So energy when the body is moving is called kinetic energy. So another form of energy is called the heat energy. The heat energy is a form of energy obtained when fuel is burnt. So when you burn something, or you're using your gas cooker to cook something, the energy gotten from that is called heat energy. When kerosene or petrol burns, it produces heat energy which can be used to cook our food and power our vehicles. So we have the sound energy. This is energy we get from our loudspeakers when electrically converted into sound energy. Sometimes sound in form of noise may cause pollution to the environment. That is just an addition. So whenever we're talking about sound energy, it's the energy produced from loudspeakers, thereabout. Solar energy, this is definitely the energy reaching us from what? The sun. This energy is responsible for our food, and it is used for drying of our clothes, production of solar electricity, and sort of. So another one is called the light energy. The light energy is the energy produced by our light bulbs or torchlight. So light energy is different from solar energy. Solar energy is from the sun. Light energy is from our bulbs and sun and torchlight. And we have the sound energy, which we've said something about. This is the energy produced by vibrating objects. Do you get? So though yeah they said sound energy, yeah they are saying sound, it's still the same thing, both from speakers, from vibrating objects, from guitars, from violins, from drums, or anything producing sound. The energy gotten from there is called sound energy. Now I want us to quickly look at some calculations. What is the energy consumed by a refrigerator of 8 ampere? You know ampere is the unit of current, and you know volt is the unit of voltage. So when you have what is the energy consumed by a refrigerator of 8 ampere and takes 10 volts to operate for about 4 seconds. So the formula, what is the energy consumed? What they are asking you there is that what is, when they are talking about what is the energy consumed, they are the formula for energy consumed in this thing is called power. Because power is the rate at which work is being done, and whenever we have rate we are always having time. That's why you can see 4 seconds in this example, which I have told you guys in class that P is equal to what? IV. But if it has time in it, if it's talking about consumption now, energy consumption, it will be P is equal to IVT, or energy consumed equals to what? IVT. So your I has been given. Your 8 amperes is your current, your 10 volts is your voltage, and your 4 seconds is your time. So it's just left for you to what? Insert. So when you insert your current that is 8 amperes, your voltage that is 10 volts, and your time that is, if you multiply everything, you get the energy consumed by the refrigerator, which is what? 320 volts. Another, that's under electrical energy, that's under electricity. So if you have a question like that, you should be able to answer it when they ask about energy consumed by any electrical device. Is what? IVT. Current times voltage times what? Times time. So another one says find the energy of a body of mass 10 kg which travels in a velocity of 4 meters per second. Now for them to be talking about a body moving, traveling, then it is what? Kinetic energy. You know, I told you kinetic energy is the energy of motion, and I told you potential energy is the energy at rest. So for them to be saying a body of mass 10 kg travels at velocity of 4 meters, that means it is moving. So the formula for kinetic energy is half mv squared. What did I say? The formula for kinetic energy is half mv squared. The formula for potential energy is mass times gravity times what? Height, mgh. The formula for kinetic energy is half mv squared, that is 1/2 times mass times velocity, while the formula for potential energy is mass times acceleration due to gravity times height. Do you get? So now for this question, they're asking us to find the energy of a body. So the energy we are looking for here is the kinetic energy. So the formula we'll be using is what? Half mv squared. So they've given us our m, which is the mass, 10 kg. Your mass is always in kg, and your velocity is always in meter per second. Your velocity is always in what? Meter or per what? Seconds. So they've given you everything. So you just do k is equal to half mv squared. And what is our m? Our m is 10, and v squared means velocity squared. That is velocity times what? Velocity. And the velocity given here is what? 4 meters per second. So it will be 1/2 times 10 times 4 times what? 4. And the answer will give us what? 80 joules. For every form of energy, the unit is called joules. Whether it's heat energy, whether it's light energy, whether it's sound energy, whether it's kinetic energy, whether it's electrical energy, the unit of energy is what? Joules. That's how you see for the two calculations, the units are in what? Joules. For the third one now, the third one says a car parked at a mechanic shop has a mass of 20 kg. The car is parked, meaning it's not moving, and stands at a height of 100 meters from the ground. The car is not moving. So find the energy that possesses if the acceleration due to gravity is what? 10 meters per second square. Acceleration due to gravity, the unit of acceleration due to gravity is what? Meter per second square. The unit of velocity is what? Meter per second. So if you notice, the car is not moving. So that means it is potential energy, because they said a car parked, it is not moving. And they are telling us that the car is standing at a distance of what? 100 meters from the ground. And I told you earlier that the formula for potential energy is what? Mass times what? Acceleration due to gravity times what? Height. So they've given us the mass, which is 20. They've given us the acceleration due to gravity, which is 10. Acceleration due to gravity is always 10 or 9.8. Acceleration due to gravity, I repeat, is always 10 or 9.8 meter per second square. So when you multiply your mass times your acceleration due to gravity times your height, you are going to get 20 times 10 times 100, and you are going to get 20,000 joules. And 1,000 joule is equal to what? Kilojoule. So it's either you leave your answer in joules or you leave your answer in kilojoule. Leaving your answer in kilojoule will be 20 kilojoule. But leaving your answer in joules will be what? 20,000 joules. I think you understand what I just finished saying. I think it's clear to you. So I'll be dropping this material on the portal, and once I'm done dropping the material on the portal with this video, I'll also drop the assignment on the assignment portal. Make sure you do the assignment. Have a wonderful day. Till our next class. Bye.